Identify the space curve given by the vector-valued function r of t equals 3 minus t, negative 2 plus 2t, 7t. So a vector-valued function, r of t equals, so we see that the r has the vector symbol over it, and the input here is t, which is a real number, so t lies on the number line, and the output of a vector-valued function is a vector where the components of the vector are functions of t. So it's kind of like three functions wrapped up into one. You have an f of t, an h of t, well I should go with g of t, and an h of t. And since this is also can be thought of as an x coordinate of a point, maybe we prefer x of t, y of t, z of t. So this is going to give us a vector which we could draw emanating from the origin and terminating at a point in space. And if we just consider the terminal point, then those terminal points will make a curve in space. It's in space because it's got three components, and it'll be a curve because t is a one-dimensional variable. So essentially we're taking the real line, which is one-dimensional, and turning it into some three-dimensional, well, some curve in 3 dimensions. The curve itself is still one-dimensional in the sense that if you're on the curve, just like if you're on the line, then you have two choices as to which direction to go, and that's it. You're very limited in one dimension in terms of your choices. So whether you're on a line or whether you're in some curve with curlicues that can only exist in space, it's still a one-dimensional object. So one input variable with three outputs that depend on that one variable will be in 3 dimensions, but it will be a one-dimensional object. So it will be a space curve. Now, what curve is it? The components are all linear. All three of them, the x of t, the y of t, and the z of t. And so this is going to make a line. We can put it in the vector form, r of t, so that we can recognize it. R of t is 3, negative 2, 0, plus t times negative 1, 2, 7. So I just pulled it apart. I took the constants, 3, negative 2, and 0, and put them in a vector here, and then the multiples of t, negative 1t, 2t, 7t, put them here. So we see that this is a point on the line, and this is the direction vector. So this particular space curve is not much of a curve, it's a line, which technically is a curve being a one-dimensional subset of whatever space that it's living in. In this case, it's living in 3-dimensional space. So it is a space curve. All the components are linear, and so you can pull it apart to make it look like the vector form of a line in space, or the parametric form if you wanted. X, which we could call x of t, is 3 minus t. Y, which we could call y of t, is negative 2 plus 2t. And z, which is z of t, is 0 plus 7t. So there's the parametric form of the line.